Okay, I'm going to do the second example. The second example taken from a question paper of November 2012. 3.2. Read as follow: a toy truck of a mass of 0.4 kg. So the mass of the object can be given in grams, it can be given in tons, but you always change it to kilograms. Rolls from rest from the top edge of the slope 1.2 meters above the lowest level, which is the ground at point A. So let's first catch the first part. It rolls down from rest from the top edge of the slope 1.2 meters above the lowest level, which is the ground. So this is how the sketch will look like. It rolls down. This is the slope. So this slope, the top part is 1.2 meters. So from here to here, it's 1.2 meters from above the ground. So the height is given for this question. The previous activity, the height was not given, we're given the slope. Okay, let's go back to the question. So this is point A where it is starting to roll. And proceeds down the slope at point B, which is 0.9 meters from the ground. So point B is also 0.9 meters from the ground. So let's say point B will be somewhere there from the ground, 0.9 meters. This is point B. Point B at that point, that is point A. Now let's read the question. You understand the diagram next? Okay. The question says, calculate the potential energy of the toy truck at A. So we are looking for the energy that it has on top of this load. So that energy at point A, formula of potential energy is EP equal to mgh. The mass of the object is given as 0.4. So m is given. Where there is m, we're going to put 0.4. G is 9.8. And the height, do you see for this question, we don't need to use sine opposite over hypotenuse because this side is given. So we're just going to use 1.2 as it is because it is the height at point A. You multiply by 1.2. Then you use the calculator to get the answer. You got 4.704. So this potential is 4.704 joules. That is the potential energy. Second question, let's see what is question number 2 is looking for. Calculate the velocity of the toy truck at B. So we are looking for the velocity. Velocity, the shortcut formula of velocity is that V equal to 2gh. You can say V equal to square root of 2g multiplied by the height. So remember, the height is the distance that is covered by the object. So this object did not cover 0.9, but it covered the difference between the two. All right. So this V will be equal to square root 2 multiplied by 9.8. Then the height is difference between the two, right? So it is 1.2 minus 0.9. You can calculate it aside and substitute h here, or we can do it in one equation. So let's get what is the value of V. Square root of 2 times 9.8 multiplied by 1.2 minus 0.9. You got 2.25, ne? Is 2.425 Velocity is measured in meters per second. Now, a question can be specific and say calculate velocity, but use the law of conservation of energy. That means that they don't want it this way. When using the law of conservation of energy is EP, we need to get what is that kinetic. Ne? Is EP loss equal to EK gain. Now, the kinetic that has been, the potential that has been lost is over this distance of 1.2 minus 0.9. So this side, we're going to calculate potential energy. It will be mg, but where there is h, you still remember bigger minus the smaller because it's coming from the top. So let's say it's h1 minus h2. It will be equal to EK gain. So this side we're going to substitute so that we can get what is kinetic first. So where there is m, it will be 0.4 multiplied by 9.8, open brackets, 1.2 minus 0.9. Then use your calculator to get what is the gain in kinetic. So in this way, we are getting what is that energy that is converted to kinetic. Two 2.4 times 9.8 times, it is 1,176 joules. So this is the EK gain. This is the energy that has been gained. Now we can use, because formula of kinetic energy is EK equal to half mv squared. This is when a question is specific that you use the law of conservation to get this V. But if it's not specific, this is the answer. So this is the OR equation. So where there is half, we're going to put half there. Multiply m is still 0.4. Ne? V squared, we're going to keep it as V squared. Where there is EK gain is 1.176. So we can first calculate this side, or we can cross multiply. Let's just get this side first. 1.176 equal to 0.5 times 4. Sorry, half times 0.4. We're going to get 0.2, ne? 0.2 V squared. So we divide both sides by 0.2. Both sides by 0.2 cancels out. Then you have your V squared equal to 88. It's only 2 decimal after the comma. Okay. Now remember, we are not looking for V squared, but we are looking for V. So we need to put square root both sides. So this one cancels out. Then you have your V. What is the square root of 5.88? 2.425. Ne? You see, we got the same answer. Here you are using the V equal to 2GH. But if a question is specific that use the law of conservation of energy, this is the method. What is lost is equal to what is gained. Now let's look at the last question. The one that I have. Calculate the momentum of the toy truck at B. Momentum is a product of a mass and its velocity. So the formula to calculate momentum is, let me do it this side. Momentum P is equal to M multiplied by V. So we do have velocity at B, is what we calculated here. M remains 0.4, but velocity is 2.425. So you just multiply these two. 0.97 only. Okay, so the SI unit of momentum, you just put the M, which is in kg, and dot velocity is meter per second. So this is the SI unit of momentum. So we got the answer for momentum at B. Now we can answer this additional question. the one that says calculate the total mechanical energy. Calculate the total mechanical energy at the bottom of the slope. So the formula to calculate the total mechanical energy is this one that says ET. ET, this is the energy total. It is equal to EP at the bottom, because it says calculate at the bottom of the slope, plus EK at the bottom. Do we have potential at the bottom of the slope? Remember, we have potential on top, né? So if it at the bottom, all of the height will be 0, né? So at the bottom, potential will be 0. But kinetic energy cannot be destroyed. So the potential it had initially on top will all be converted to kinetic. So the kinetic at the bottom will be equal to this answer. It will be equal to this answer. So it is 4.704. The answer for total mechanical energy is 4.704 joules. So this is how you solve it. If a question says something is projected, is going up, let's say you have from this point projected vertical upward through a distance of 5 meters. Now a question will say, calculate what is the kinetic energy 3 meters above the ground. Remember, it's still going up, né? So it means the kinetic here will be the same as this potential. You don't